So in GOC, General Organic Chemistry, we are doing summary. Today's date is 30/10/2025. First point, in GOC, there is always you have some of the what should I say reactant. When it react with the attacking reagent, it form product. Reactant form product with some intermediate and attacking reagent. Correct. Second, in GOC you will see bond cleavage, breakdown of bond. This cleavage can occur in two ways: equal breakdown, homolytic, and if positive and negative charge is created, heterolytic. Hetero means different, lytic means breakdown. Homolytic usually lead to the formation of free radical, and heterolytic lead to the formation of carbocation and carboanion. I think I should ask question from you rather than explaining everything. Okay? Anvita, what are the different type of reagent we have? First is electrophile. Anvita, tell me what is electrophile.
सर
Any
क्या
molecule.
इलेक्ट्रोफाइल
What is
डेफिनेशन?
electrophile? हाँ.
हाँ, इलेक्ट्रॉन डिफिशिएंट होते हैं.
So electrophile that have positive charge, or because they are electrodeficient, sometimes neutral molecule are also electrophile because of the electron deficient nature. They don't have positive charge, but they are electron deficient. That's why electrophile. Anvita, Pratigya, nucleophile.
मतलब
What
वो
are
डोनेट
nucleophiles?
करते हैं और नेगेटिव चार्ज डोनेट करते हैं.
Electron donate करते हैं. So nucleophile either have negative charge or they have lone pair. Because they can donate those lone pair, they are nucleophile. Varinder, what is ambidendant nucleophile?
Two electronic sites.
So within the same molecule, two different molecule can donate their lone pair or electron. That is ambidendant nucleophile. Example, in case of cyanide, both carbon and nitrogen can donate. In case of NO2, both nitrogen and oxygen can donate. In the case of SCN, sulfur and nitrogen both can donate. Then next topic is intermediate. We have different type of reaction intermediate. Chandana, what is reaction intermediate?
So it forms in the middle of the reaction.
Yes, molecule that form middle of the reaction not present in the beginning as well as in the end. Example, first carbocation. Carbocation, carboanion, free radical, all these are the intermediate, and that is what we have in our syllabus as well. Carbocation, carboanion, and free radical. Anvita, tell me something about carbocation.
So it has positive charge
Uh,
and three bonds are there, I think.
uh,
sp2. Yeah, okay, I have written
hmm.
that.
So, and carbocation are the molecules that have positive charge on the carbon. They have incomplete octet. It means there will be six electron, incomplete octet. So they are dimagnetic because electron present in pair. Because of the positive charge, also electrophile. sp2 hybridization, and because of that it is planar, and they have incomplete octet because of the electron deficient nature. Correct. Pratigya, carboanion.
नेगेटिव चार्ज रहता है पैरामैग्नेटिक होता है, न्यूक्लियोफाइल होता
हाँ
है, sp3 होता
हाँ
है, और
sp3
ऑक्टेट होता है,
हाइब्रिडाइज्ड
और जो मेथिल होता है, समथिंग
distorted tetrahedral. It means logically it should be tetrahedral, but shape is distorted because of the lone pair. Correct? Because of the lone pair. Brinder free radical.
Negative charge,
Neutral.
7 electron, incomplete octet row, and paramagnetic.
Paramagnetic because electrons are not present in pair and they are electron deficient because one electron shortage. So this is the basic introduction of carbocation, carboanion, and free radical. After that, we have electronic effect. Electronic effect means Chandana,
So which affects the chemical reaction.
which affect the chemical reaction means movement of electron. Movement of electron is the electronic effect. First, we have actually four effects. One is inductive. Anvita, what are the other effects?
Electromagnetic, mesomeric,
Hmm. Continue. Make it fast
mesomeric.
because this is like kind of one shot. Electromagnetic. So we have four effects: inductive, resonance or mesomeric, hyperconjugation, and electromagnetic. Out of these four effects, first three are permanent effects. There is a permanent change, but last three only temporary effect. It means if you remove the reagent, it will restore its original nature. Okay. So first start with the inductive effect. In case of inductive effect, what happens, Pratigya?
displacement of sigma electron,
Uh, Polarization of sigma bond,
sigma
right?
sigma bond,
So movement of sigma electron, correct? And it is dependent on the distance. The more distance you increase, impact will be less. Okay, so you can say inductive effect is inversely proportional to the distance. More distance, less inductive effect. Correct. Example: if you see inductive effect at ortho is maximum, then meta, and in the end para. Correct. So when we talk about the how we apply this inductive effect, you will see in case of carbocation, you always know whether it is like resonance or hyperconjugation or inductive effect. Energy is directly proportional to the charge, more energy, and less stability. Because in this chapter we'll talk about stability, see how stability is affected. And in this case, stability of the carbocation is directly proportional to the plus I effect and inversely proportional to the minus I effect. It means if there is an electron donating group will increase stability, electron withdrawing group will decrease stability. Of what? Carbocation. Remember, carbocation. Okay. It means uh, plus resonance effect will increase stability and minus resonance effect will decrease the stability. Okay. And everything is opposite in case of carbon. है ना? In case of carbon, everything is ulta. Example: in carbon, stability will increase as minus I effect is more, or electron withdrawing group is more, or uh, minus R effect is more. Okay, so carboanion is ulta of carbocation. Got it? Even because we are talking about stability, you can also talk about the acidic character together. How acidic character is affected? You will see acidic character means how easily we can release as positive ion. Okay. In the simplest term, you will see if you have electron withdrawing group, it will increase acidic character. Electron withdrawing group will increase acidic character. It means it will reduce basic character. Okay? It will reduce basic character. And yeah, that's all. If acidic character is increased, Ka will increase and pKa will decrease. Correct? And you know, as positive um, concentration, if there is a more acidic character, as positive concentration will be more, and because of that, pH will be less. Make sense? Yes or no? In case
Yes.
of donating group, everything will be ulta. Electron donating group decrease acidic character. It means it increase basic character. If it increase basic character, then Kb will increase, then pKb will decrease because Kb and pKb is ulta of each other, like H and pH. Then you will say ki OH negative concentration in this case will increase and pH will also increase. More OH concentration, pH will be more. That is special case in case of pH and POH. And it will cover 50% of your chapter, trust me. 50% of the chapter is about acidic character, basic character, as positive concentration, pH, electron withdrawing group feedback. You just remember this part. Everything else you can correlate if you just remember electron withdrawing group, increase acidic character. Got it? Okay. In doubt? Any doubt?
No, sir.
No, sir.
No, sir.
No, sir.
And next part is resonance effect. Resonance effect is also known as mesomeric effect. And in this mesomeric effect, there is a movement of pi electron. Movement of pi electron. But these pi electrons are moving in the alternative single and double bond. Alternative single and double bond. Sigma bond and pi bond. Resonance, in case of resonance, resonating structure is also known as canonical form or canonical structure. Canonical form or canonical structure. Real structure is always resonant hybrid. Hybrid means mixture of all. Resonance hybrid means mixture of all. Huh? So in this case, you will see all the canonical form structure are hypothetical. We just assume them theoretical, but real structure is resonance hybrid. Okay, and what else? Anything left? Yeah. So when I said there is a pi electron movement continuously, delocalization of pi electron, you will always see ki not only sigma and pi bond. It could be alternative sigma pi bond, but there could be relation of pi bond conjugation or pi bond and carbocation conjugation, pi bond carboanion conjugation, pi bond free radical conjugation. Remember this. everything is possible. Pi bond, pi bond carbocation, carboanion, or free radical. That all will show this resonating effect. But one thing, one special case, this if you have this resonating structure and there is a positive charge on it is highly unstable. Whether it is positive charge, negative charge on the ring, it is always unstable. Okay, you will see this kind of question in many places. Stability. See how resonating structure will increase the stability. There are few rules. If you have complete octet, then molecule is more stable. If it is non-polar or neutral, it is more stable compared to the charged molecule. Okay. If negative charge is present, negative charge is present. Uh, if negative charge is present on more electronegative molecule, it is more stable. Okay. If like charges are close to each other, then maximum stable. Unlike charge are far away, more stable. So these are the few criteria that will tell you which molecule is more stable. Complete octet, neutral molecule, negative charge on more electronegatives, like charge close, unlike charge far away are more stable. And one more thing, more resonating structure is more stable. If you can form multiple form, then it is more stable. Correct? Then we talk about aromaticity. Chandana, what is the difference between the aromatic compound and anti-aromatic? And you also tell me non-aromatic compound also, Chandana. Usually these are the cyclic molecule. These are also cyclic. We don't know. It could be cyclic or non-cyclic, both. Anything is possible. It should be planar, means sp2 hybridization. It should also be planar, sp2 hybridization. Non-aromatic could be anything. Okay. Here you should have complete conjugation, means resonance. Here same thing, complete conjugation. But in anti-aromatic, everything should be in the conjugation form, but non-aromatic, anything is possible. Last and the most important difference is Huckel rule. Huckel rule is applicable only in the aromatic compound 4n plus 2 pi electron in a cycle. Here it is only 4n pi electron in cycle. That is the biggest difference in the aromatic and anti-aromatic. 4n plus 2 Huckel rule, aromatic, 4n anti-aromatic. Got it? And next is, what should I tell? Hyperconjugation, third effect. Barinder, what is hyperconjugation effect?
Complete transfer of sigma bond.
Complete transfer of sigma bond. So this is also known as no bond resonance or Baker and Nathan effect. No bond resonance. It look like resonance, but one bond will be broken, also known as Baker and Nathan effect. Scientist name. Correct. What should be the criteria in this case? You should have alpha carbon and this alpha carbon should be sp3 hybridized. And on alpha carbon, there must be alpha hydrogen present. Only then it can happen. Stability, if you talk about of carbocation, more number of alpha hydrogen, more stable. More number of alpha hydrogen, it will be more stable. Okay. And anything else? Yeah, this is the most important thing. It is distance independent. It does not depend upon the distance like resonance effect. In case of one thing I have to write in the resonance effect, that in case of resonance, this is also distance independent. It means if you take ortho and para position, resonance effect will be same. And at matter, Pratigya, mesomeric effect at matter will be 0. It means no effect on the matter position. Correct? If you see in the hyperconjugation effect is more stronger than inductive effect, but less, more than inductive effect, but less than the resonance effect. Hyperconjugation is stronger than inductive, but weaker than resonance effect. Correct? Any doubt? In case of alkene, if you take double bond, how to decide whether a alkene is highly stable or not? Just look at the hydrogen effect, hyperconjugation effect. Sorry, it depend upon the hyperconjugation effect means it depend on the alpha hydrogen. More the number of alpha hydrogen, stronger the hyperconjugation effect, and such alkene will be more stable. Okay. Next topic is heat of hydrogenation. Chandana, how heat of hydrogenation decided? Chandana, are you there?
Yes, sir.
Hmm.
So that
So,
concentration.
no. Heat of hydrogenation means what is the amount of energy released when you add 1 mole of hydrogen in 1 mole of the like alkene, only one unsaturated alkene. Then what is the amount of heat release? Amount of heat released when you add hydrogen in 1 mole of unsaturated compound. It could be double bonded, triple bonded, multiple double bonded, hydrocarbon, hydro and carbon and hydrogen. Okay. How it will be decided? Heat of hydrogenation is basically energy. And you know, energy is inversely proportional to the stability. Rinder, if number of pi bond is more, what will be the impact on the heat of hydrogenation?
Increase.
Increase. So it directly depends upon the number of pi bond. More number of pi bond, less stable and more energy. Okay. So this heat of hydrogenation, just remember this is a kind of energy. And you know energy and stability relation already. Correct? And remember this thing is extremely important. When you see mesomeric effect, so ortho and para is same and meta is 0. But in case of inductive effect, ortho is maximum, then meta, then para. Okay. What else we left? Free radical, bond dissociation, and yeah, free radical stability is same thing. If you consider the stability of free radical, it is same way how you see the carbocation. Just remember, it is almost same as carbocation. You know, in carbocation, tertiary carbocation is more stable, then secondary, then primary. Here you will have same thing. More number of alpha hydrogen, more stable. More resonance, more stable. Correct? And more stable, less energy. That's why you will see कि bond dissociation energy is a kind of energy and it will inversely proportional to the stability. More stability, less energy, like heat of hydrogenation. Correct? And what else I missed? Tautomerism is one thing we are left with. Acidic basics, and we did feasibility of reaction. Whether a reaction can occur or not, that is the feasibility of reaction. Okay, so feasibility of reaction occur only when a reaction go from the strong acid to the weak acid. If a strong acid convert into the weak acid, then reaction can happen. Example, if you have CH triple bond CH, react with the strong base and it convert into CH triple bond CNA positive, this is negative, and H2O. So you know here it is weak acid. Water is strong acid. So this reaction cannot happen. It is not feasible. I said strong to weak, not weak to strong. So this cannot happen. And last effect is the electromeric effect, which is the only temporary effect compared to remaining three. And in this electromeric effect, pi electron will move in the presence of temporary, in the presence of the attacking reagent. If attacking reagent attack on the carbon, example, you have this. When pi electron move in the presence of attacking reagent, it will be negative, positive. Attacking reagent will attack on the same carbon, then it will be the plus electromeric effect. If it is ulta, if it is goes here and cyanide will go to the another carbon, it will be the minus effect. Movement of pi electron in presence of attacking reagent is electromeric effect. Okay. And last topic. Actually, this tautomerism is very big topic, but because we are doing just simple revision, so this is also known as keto enol form. How it happened? There should be alpha hydrogen. There must be alpha hydrogen. Got it? And you should have one like carbon that have only sp3 hybridization. Carbon with sp3 hybridization only, then it can happen. Example, CH2 COH. So this is the alpha carbon. Hydrogen present along with it is alpha hydrogen. So this carbon is sp3 hybridized. Alpha hydrogen are present. So what will happen? Tautomerization can occur. Okay? Tautomerization can occur, and this hydrogen will go here. So what will happen? CH2 double bond C OH H. This is tautomerization. So alpha hydrogen is must, and sp3 hybridized carbon is must. And that is the all about the summary of this. Tell me, guys, do you have any doubt from this topic?
Not
No. If you want keep the quickest summary in just 5 minutes, complete GOC. Quickest. And why I'm trying to tell this quickest? Ki how revision works for you. We spent so many days and now we are able to revise the same thing in the minimum time. We have four effects: inductive effect, electromeric effect, resonance effect, and hyperconjugation effect. Okay. This inductive effect is the distance based and uh, movement of the sigma electron. Electron electromeric effect is only temporary effect where pi electron will move in the presence of the attacking reagent. Resonance, strongest effect, and there is a delocalization of the pi electron. Hyperconjugation effect, no bond resonance. There will be the sigma electron movement. Correct. When it comes to the stability of any compound, just remember its stability will inversely proportional to the energy, inversely proportional to the charge. This is the biggest tool. When you talk about the stability of carbocation, carboanion, everything, it all depends how much charge you have. Less charge, more stable. Okay? Less charge, more stable, and that's what how it works. Example, if you see, if you have electron donating group, it give electron to the carbon compound. Example, if you have carbocation, it will give electron and it will make more stable with less charge. But in case of you have carbanion electron donating group will give more electron, more charge, less stable. Correct. So carbocation, carbanion, free radical stability all depend upon the charge. Charge. Electron withdrawing group increase acidic character, decrease basic character, increase acidic character Ka, decrease pKa, increase H positive ion, and decrease pH. Ulta is same there for everything. Correct. And what else? Heat of hydrogenation or bond dissociation energy are the kind of energy, so they are inversely proportional to the stability. In case of aromatic, you should have cycle, you should have planar molecule, but most important is 4n plus 2 pi electron. In case of anti-aromatic, everything is same, cyclic, planar, conjugation, but pi electron will be 4n. Okay. Feasibility of the reaction. If any reaction move from strong acid to the weak acid, you will call it as a feasible reaction. And tautomerization is a kind of isomerism, you know. In this case, you should have alpha carbon with sp3 hybridization, and you should have alpha hydrogen. And then there will be keto enol form. Keto form convert into the enol form. Tell me, guys, how much time I took to revise this quickest summary. I left this electrophile could be positive, could be electron deficient. Nucleophile could be negative and can have lone pair. Done. I think I covered most of the part. Yes or no? Yes or no?
Yes.
So tell me one by one. Pratigya, how was the revision of GOC? Complete GOC. Basic revision.
हाँ सब याद रहेगा.
Barinder,
अच्छा था.
Chandana,
Sir, I understood well.
Anvita.
हाँ सर अच्छा था.
Can you say कि now you can solve all the basic question because you can revise the whole GOC in just 5 minutes. Just 5 minutes. And this is what you require for every single chapter, whether it is physics, chemistry, or biology. If you can't revise full chapter in 5 minutes, it means you did not do the chapter really well. And now you can solve question. Okay. Uh, let me check the. Hey guys, this is 2025. Once you look at this, you will feel कि sir, this question is really difficult, sir. But uh, hmm, among the following, correct order of bond dissociation energy of the carbon hydrogen bond. Now you know that if bond dissociation energy we are looking for, we have to look for stability. Correct? More stability, less bond dissociation energy. Out of these compound, you know resonance is highly stable. So bond dissociation energy will be less. Correct? Make sense? So bond dissociation energy will be less. So here you have in first case, here you have carbon, hydrogen, and because this triple bond carbon will attract electron toward it. So can we say in this case hydrogen can break easily and bond dissociation energy in this case will be high? Yes or no? Bond
Yes.
dissociation energy in second case is more because bond is strong. If bond is strong, then it requires more energy. Correct? And in case of third, you have to see कि this is highly stable. This bond is stable and that's why bond dissociation energy will reduce. So you have to look for the S character. Example, here it is S, sp to a hybridized carbon. Here it is sp and here it is sp3. Yes or no? Any doubt?
No, sir.
You know if S character is more, then carbon hydrogen bond will be stronger. And if carbon hydrogen bond is stronger, then bond dissociation energy will be high. Yes or no? Yes or no?
Yes.
Yes, sir.
Now you tell me, Varinder, in this case, what is the S percentage? Percentage of S. 33%, one third.
Yes.
Chandana, what is the S character in case of SP?
50%.
50. Anvita, what is the S character in SP3? One fourth. 3P and 1S total for one fourth. Correct. Where we have maximum S character in second number, first, and then third number least. Yes or no?
Yes.
So bond dissociation energy inversely proportional to the stability. And in this case, if you have more S character, so carbon hydrogen bond will be stronger, more bond dissociation energy, less stability. Correct? Any doubt? Yes or no? Stereoisomers, IUPAC name.
When will you finish your class?
Just 5 minutes.
Only 5 minutes.
Chandana,
I'm ready for it. So,
methyl group attached to the positively charged carbon atom. Stabilize the carbocation. What is the rule for the carbocation stability? Chandana, stability of carbocation.
Sir,
Stability.
alpha hydrogen.
Electron donating group.
Tertiary is greater than secondary.
Your voice is breaking. Tell me whether I am right or wrong. Electron donating group, when attached to the carbocation, it will give electron. Charge will reduce on the carbon, and if charge reduce, it is more stable. Yes or no?
Yes.
So electron donating group increase stability. Now methyl group is electron donating group. When it attaches to the carbocation, it increases stability. But what should be the main effect?
So negative inductive.
Hyperconjugation effect. Alpha hydrogen, na? Because plus H, CH3 have 3 alpha hydrogen, and 3 alpha hydrogen means what? P, more hyperconjugation effect, more stability. Make sense?
Yes.
Huh. So this is what you should understand. Here it is plus I effect or plus H effect. Electron donating group plus I
Yes, sir.
or plus H effect hyperconjugation. Next, Pratigya, most stable carbocation. Again, same type of question. Pratigya,
Last one.
most stable carbocation, electron donating group will increase stability of carbocation or even plus hyperconjugation effect will increase stability. Now see, if this is the carbocation, so this carbon will have one hydrogen. This carbon will have how many hydrogen? Two. So how many alpha hydrogen will be here? Three. Here. These three. These two. Five alpha hydrogen. Here. This carbon. Only one alpha hydrogen. And last three, two here, and 2 this side. Total 7 alpha hydrogens. So which one is the most stable? Fourth. What is the sequence? Because we are learning for the NEET, not for the question. So maximum will be D, then B, then A, and in the end C. Yes or no, guys?
Yes, sir.
Okay, just look at the alpha hydrogen because plus I effect or hyperconjugation effect increase the stability.